Hello, good morning everyone. Today we are going to study software testing unit 2 session 13. In the previous topic we have studied the concept integration testing and the method of integration testing, that is top down integration. In today's topic we'll see the remaining methods of integration testing. So first we'll see bottom up integration testing. By the name only you'll understand bottom up integration testing means you are going to start integration testing from the bottom modules and then to the main modules. In top down integration testing we would start the integration testing from main module then to the sub modules. Now here this is a reverse way of a top down integration testing. In this method we are going to start testing from the bottom level modules, that is lower level modules, to the higher level modules, that is main modules. In this method, where the components for a new product development become available in reverse order starting from the bottom. In bottom up integration approach, all bottom, that is sub modules level integrated sub modules are tested first. That means all bottom level sub modules you are going to start testing first and then you are going to move to the higher levels till the main module. You can see in this diagram, so you are going to start testing integration from the bottom level modules and then you are going to reach to the top level modules or the main modules. Consistent approach to integration testing in which lower level components are tested first and then used to facilitate software testing components at higher levels. In this approach, testing is conducted from sub module to main module. If the main module is not developed, a temporary program called drivers is used to simulate the main module. So it uses drivers. Drivers is nothing but upstream connectivity. Now in this integration testing method, you are going to start testing from the lower level modules, and if the higher level modules are not ready, then a temporary program, a dummy code is written and that is called as drivers. So these drivers call the upper level modules. It calls the upper level methods for whichever that module is connected. That means it is upstream connectivity. It is used for upstream module connectivity. So this is the diagram of bottom up integration testing. So first the bottom level modules will be tested and then see from 1 to 5, then from 2 to 6 to 2, then 6 to 3, then 7 to 8. Then you are going to start testing from 8 to 5, 5 to 1, then 8 to 6, 6 to 2, then 8 to 6, 6 to 3, and so on. See in this. So bottom level modules are tested for, and we consider this as component 1, component 2, component 3, and then we consider this as component 4 and 5. So the flow between this will be tested first. The flow between this bottom level modules will be tested first and then it will move upwards. And if the upper level modules are not ready, okay, if these upper level modules are not ready, then drivers are used for calling those modules for temporary purpose. So the drivers are nothing but a dummy code which is specially used to call the methods of that particular module. So the drivers will be connected here to call that particular method. So this is the table how the steps are taken for bottom up integration testing. So first step is 1 to 5, then 2 to 6, 3 to 6, as I told you here, 1 to 5, 6 to 2, then 1 to 3, then all together same one. Okay. Stubs and drivers we already know why we use and why we use stubs and why we use drivers. You can see this is a component. Okay. If the above components are not ready, then drivers are used to call that particular method of module, and we use stubs, and if the lower level modules are not ready, then we use stubs to call that particular lower level modules method. So a component that calls the tested unit. Okay, component that calls the, okay. So these drivers and steps are nothing but the dummy code which will call the method of drivers or stubs. So advantages of this method is, advantages if major flaws occur toward the bottom of the program. This is obviously advantageous when the error is on the bottom level modules. Then our time is not wasted there, and we can detect the errors very early. No time is wasted waiting for all modules to be developed. Okay. So whenever your bottom level modules are ready, then you can start testing it by integrating it together. Disadvantage is that critical modules which control the flow of application are tested last and may be prone to defects. So this means the main modules which are, okay, from where the logical flow start. The logical flow start from the top to the bottom level. So the flow will be little, the flow of execution will be not understand clearly, and because of that it can cause the errors or the defects, because there is no proper flow. Logical flow we are not following here. First we are integrating, and then we are testing the logical flow there. Early prototype is not possible. So how is the proper flow? How is the proper software prototype? We will not understand here because we are starting it from bottom level. See, these are the bottom level modules. So whichever modules are ready, we'll be start integrating it and testing. So once a set of bottom modules are completed, we would build a driver. So driver will be used if the higher level modules are not ready at the next higher level to run the integration test. Continue this process until all the completed modules are tested. Next method we'll see bidirectional or sandwich integration testing. So this method is a combination of earlier two methods, that is top-down integration testing and bottom-up integration testing. So this bidirectional or sandwich integration is a combination of both, where both methods will be followed. You can also start testing from the main modules. You can also start testing from the bottom level modules. So whichever is ready first, from there you can start testing, whether from main module or whether from bottom level modules. It's a combination of top-down and bottom-up integration testing. Here, top modules are tested with lower modules at the same time. So top level modules will be tested with the lower level modules at the same time. So lower modules are integrated with top modules and tested. So this strategy makes use of stubs as well as drivers. So as I told you, whichever modules are ready, you are going to start testing. If the higher level modules are ready, you can use the stubs and you can start testing. If the lower level modules are ready, you can use the drivers and you can start testing. A driver is a function which redirects the request to some other component. That it calls the method of that particular modules or component. Stubs simulate the behavior of a missing component. So it is nothing but stubs are downstream connectivity and drivers are upstream connectivity. After the functionality of these integrated components are tested, the drivers and stubs are discarded. Okay. So once these all integrated modules are tested, whether it is a top level modules or bottom level modules, then drivers and stubs can be discarded. See, this is how it is tested. If the bottom level modules are ready, then you can start testing from component 1 to component 6, component 1 to component 7, component 1 to component 8. If the bottom level modules are ready, then you can start testing from component 6 to 2, component 7 to 3, 7 to 4 and 8 to 5. Okay. And if earlier modules are not ready, then you can use stubs and drivers. See, 6 to 2 steps you can carry out, 6 to 2, then 7 to 3, 3 to 4, then 8 to 5. Okay, and once the higher level modules are ready, you can start testing combinedly. See, 1 to 6, 6 to 2, and 1 to 7, 7 to 3, 3 to 4, and 1 to 8, 8 to 5. So combination of both here, you can start testing from top as well as bottom level modules. So you can see in this diagram, if these two bottom level modules are ready for testing, then we use the drivers for upstream connectivity, so that for temporary purpose it can call the methods of that particular module. You can see here, if these two are completed, we may choose to build a driver to test, may also build two green stubs. See, it can also build two green stubs. Okay, it can also use stubs for downstream connectivity. So both. So if these middle modules are ready for testing, so it can use either drivers upstream connectivity, or it can use stubs for downstream connectivity integration testing. And if this is completed first, see, if this is completed first, then we may choose to build three stubs to test. See, below there are three modules which are connected for that particular module. Stub 1, stub, so you need here stub 1, stub 2 and stub 3. If these modules are not ready, then you can use stubs for downstream connectivity. So once a module is completed, then we build the appropriate drivers or stubs to perform the integration test. So this process is continued until all the modules are tested. Next method is Big Bang or system integration testing. All components of the system are integrated and tested as a single unit. Now here the name system integration means all modules. Okay, we have to wait here until all the modules are developed properly, and when all the modules are developed completely, then all together will be tested at a time as a single unit. So we have to wait here until all the modules are completed, and then we are going to test all together as a single unit. So this method, it reduces testing effort and removes duplication in testing. So because we are not using here any stubs or drivers, because we are waiting for the other components to be developed properly and tested. So it reduces testing effort and it removes the duplication in testing. Duplication in testing, like instead of using the stubs and drivers and testing same again and again, that will be reduced here. It is ideal for product where interfaces are stable with less number of defects. So this method is good for a product where the interfaces are stable and with less number of defects, where majority of components are already available and very few components get added or modified. So this type of method can be used for the product where already the ready-made components are available, and very one or few you are going to add in that. Then for such type of product, this method is good. So good for small systems, but not for enterprise level applications. So this, as I told you, it is good for small systems, small projects, but not for very complicated or complex software products. So in this Big Bang method, so all modules will be tested together. So all modules have to be completed, then the testing will be applied here, integration testing will be applied. So these all flow will be tested at a time. First flow, second flow, third flow, fourth. So all will be tested at a time. So wait for all the modules to be completed and perform one round integration testing. Then test all the integrated modules together. See, same example we are taking. So this is module 1, module 2, 3, 4 and 5. So all the modules will be tested together. All the flows will be tested together. The flow between these, how is the flow from login to current balance, then from current balance to deposit, login to current balance, and then to withdraw, and then to transfer. So wait for all the modules to be developed, but this will be very time consuming because we have to wait here for all the modules to be completed. Okay. In earlier methods we have seen that whenever the modules are completed, we start testing it. We start combining the modules and we perform the integration testing. But here we have to wait. Difficult to trace root cause of bugs. As we are combining, as we are waiting here all the modules to be ready and all together we are testing, we may not able to detect exactly where is the error. Error is in the component module or error is in the flows or interfaces. So disadvantage, it is very difficult to isolate the defects found, as it is very difficult to tell whether defects is in component or interface, which I told just now. Difficult to find out where exactly the error is lying, whether it is in a component or in the flows interface. Some interface links to be tested could be missed easily. Yes, some of the flows can be, or the interfaces can be missed out because there are a lot of flows, because together we are testing at a time. So more number of flows will be there, number of interfaces will be there. So some of them can be missed out. Since the integration testing can commence only after all the modules are designed, testing team will have less time for execution in the testing phase, as most of the time will be wasted in waiting for completion of all the modules. So at the end, the testing will be having less time for execution in the testing phase. So one type of pressure comes on the testing team to complete all the testing of the interfaces, flows and components together at a time. Choosing integration method. So these are some factors and which integration method can be selected for these factors. So if you are clear with requirements and design, then go for top-down integration testing. If you know proper flow and all. Dynamically changing requirement, design and architecture means which is not fixed, it keeps on changing. Then it's better go for bottom-up integration testing. Changing architecture and stable design, you can go for bidirectional integration testing. Limited changes to the existing architecture with less impact. That means already the system is available and somewhat some changes you are doing in that. Then you can go for Big Bang integration testing. And if there is combination of above all factors, then select one of the above after careful analysis. So we have completed here the methods of integration testing. In the next session, we will see some new topic. Thank you.